Hey Valerie, do you think it's okay that I just ate that cake in the fridge?
Yeah, I'm pretty sure Fiona left that in there for all of us to eat.
Good. I have been thinking about units and how they relate to quantities lately, and am trying to understand some things that I don't think I was taught very well. I understand that adding is just an extension of counting, and when I count, I need the same unit. So 2 linear inches plus 3 linear inches equals 5 linear inches. And if I had 2 teddy bears plus 3 teddy bears, I would have 5 teddy bears. But when I multiply, units are trickier because I don't really multiply a unit by the same unit like I do with counting, addition, and subtraction. For instance, if I multiplied 2 linear inches by 3 linear inches, I don't get 6 linear inches. I get squared inches. The operation of multiplication does not require the same unit. In fact, you can't have a problem that has all the same units with multiplication.
Yes, that is correct. Considering the measurement units in physical space even has a name. It's called dimensional analysis and is really important to mathematicians, particularly engineers, physicists, chemists, and even architects.
But objects are even trickier than measurement units. For instance, if I have teddy bears, I can't really multiply 3 teddy bears by 2 teddy bears. It doesn't make any sense. There's no such thing as a squared teddy bear. I have to multiply my teddy bears by groups or by cost, or by some other unit than teddy bears in order for the problem to make sense. Isn't that correct?
Yes, objects are never really multiplied by the same object. It is important to think through your units as you work any mathematics problems.
So, 3 teddy bears times $2 equals $6?
If you can bear with me here, more precisely, I would say that 3 teddy bears times $2 per teddy bear equals $6. Do you see how the teddy bears, or the unit of teddy bears, cancels out in that equation?
Okay, so that's what canceling out the unit means. I thought canceling out meant I could just slash through things at random times. Do you mean we could be actually making sense of this in elementary school and I have to wait until physics and chemistry?
Yes. The math actually makes more sense when we pay attention to what units we are counting, adding, subtracting, multiplying, or dividing. It helps us integrate language into math too, and helps students keep track of the quantities in the problem. It also helps students see the different structures involved in the different operations.
So you mean students might actually understand what they're doing? That is a novel idea. I think it might catch on. But what if I had 3 rows of teddy bears by 3 columns of teddy bears? Is that teddy bears times teddy bears?
No, that is not really teddy bears times teddy bears. It's 3 rows of teddy bears times 3 teddy bears per row equals 9 teddy bears. See how the units cancel out again?
Okay, I see that. It seems like a lot of language. Isn't it easier to just leave that all out?
No, not if you want students to actually be prepared for higher math. They need to see these connections.
So let's see if I understand this. I must add and subtract with like units, and my result is in terms of that unit. But I can't multiply like units and get that same unit. For instance, I can't multiply dollars by dollars. There is no word problem that would make sense where I have $3 times $2 and get $6, is there? And there is no such thing as dollars squared either.
Yes, I agree. But you probably did not spend a lot of time thinking about this important issue in school, so it is important to think about it now.